So next in this session, we'll see pointers. But before going into pointers, I would like to touch upon some things related to address and memory. Okay. Why? Because pointers deal with address. So every system, like say, be it an embedded system or a computer system or a network system, or you might use a controller or a microprocessor, correct? So to run any program. So that has a finite memory. Okay. So say an example, a controller might have a 4 MB of flash and 128 KB of RAM. Okay. And we cannot use all of this to write codes. We also have to use it to store data. Okay. So a C program comes and occupies this memory. Okay. Meaning whatever we write has to go and sit somewhere in the physical memory. Correct? Because if you see a C program executable, that is 1 KB, 2 KB, 6 KB. That 6 KB has to go and sit somewhere in the memory. So that will be part of either this 4 MB or 128 KB. So what and all is stored in C program? Everything, functions, variables, constants, everything occupy memory in C program. That's why if you define more number of variables, your program tends to increase in size. Okay, and it will occupy more memory. Okay, meaning if you define an array of n,000 bytes integer, what you're doing is you're potentially consuming 4,000 bytes. That's close to 4 KB. Yeah. So if you compare this system where only 128 KB of RAM is present, so you're almost utilizing 4% of the RAM available just for one variable. Okay. So I just wanted to touch on this because to understand the code with respect to memory. Okay. When we define a variable, we to assume in our mind, or we to create a map in our mind that, okay, this will go and sit in some physical memory, right? So how do we, physical memory as in, say, a more number of transistors, the bigger the memory. Okay. You can go and search something about the memories, how it is stored. So, but every controller and the processors of the computers come with memory. Okay. So the codes will get executed from these memories. The CPU will take instructions from these memory and execute. Okay. So that's why understanding the memory in the context of C program becomes important. It will set the context to the pointers. When we start discussing pointers, the address and the memory keyword, what we use there, and the importance start to make sense. Yeah. Okay. So then how do we access? Okay, we have a address and C program occupies memory. Okay, what do we do with this knowledge? Okay, C program occupies memory, variable occupies memory. So as a developer, what should we do with this? Correct. There are many use cases, and this pointers is a very good skill, C programming skill. You can do a lot of stuff with this. Okay, so we can access the addresses directly and use them in our C program. Yeah. So this is a flexibility, or this is an advancement in the C program. So we just saw what are the addresses and memories. Okay. And we also know that the way to access addresses is via pointers. Okay. So then how do we use these pointers? Okay. That's what I'm trying to explain here. Pointer is a type of data type. Okay. It's again a type of data type. So you can see here int PTR, and there is one extra star. Okay, this is what makes this PTR a pointer. int we all know, and the star PTR is a variable. Okay, whenever there is a star, the dereference pointer is there. It's a pointer variable. Okay, so this is a general syntax. So this is a pointer. So what will PTR hold? PTR will hold the address. Address of what? Correct. It's just a pointer variable definition. Okay, when I use this, just this one statement, int star PTR, I am just defining one pointer variable. Okay, it's not at pointing to any address. It's not at done. Okay, that we'll see in the slide below how to do it. So this is the basic syntax in star PTR. And how do we use it? Okay, so this we saw before in the previous slide, that int star PTR is a pointer type. Okay, and int var is a variable. Consider, I mean, this we learned, this also we learned. Now what we are doing here makes it special. Okay, PTR equal to ampersand of var and of var. Correct. So what does this statement mean? Whenever we use this symbol and with any variable, it will give the address of this variable. So this variable is stored somewhere. It is 4 bytes in size. 4 byte has to start at some address physically. Physical address as in it can be from 0 or 5000, go on. Okay, so this is the address. When we use this one, the symbol, it will give the address of var. Okay, now we know pointer. This is a pointer. What it will do? It will point to an address that we are achieving in this statement. We have a pointer. We extracted the address. We are making it point to this address. Okay. We know that we defined a pointer. Now pointer is pointing to an address. Okay. Pointer always points to an address. So pointer is also, okay, I mean, then address is of what type? I mean, is it a character type? It's an integer type, correct? Meaning, if I have an address, let's take it in the next slide. Yeah. Say, okay, extending the same one. Consider a variable int var equal to 10. And this is a memory footprint which I am trying to depict here. And these are the addresses. Okay, these are the physical addresses, not fixed. Consider these are the addresses. Okay, and consider variable is stored at this address. There is some data above, some other data below. Variable is stored here. So when we do AND of var here, it will give address in which this variable is residing. That is this. So AND of var is this, and the variable is 10. When we do star PTR, star means here we defined, but now, and this is pointing to this address. Now if you want to extract what's present in that address, just use star PTR. It will give you what's present inside this address. Then what is PTR? PTR will simply give you the address. Okay, this we'll see in the code examples. In this example, I'll try to demonstrate what are the addresses. What is the address of a variable? Yeah. So whatever we learned in the last 2 slides, try to show you practically here. Okay. So I have a main function. So inside this, I'll define one pointer. So as we saw, the star makes this pointer, this PTR a pointer variable. Okay. Pointer is also a variable. Pointer is also a variable. So variable. Okay. So this pointer, okay. So just write here. PTR will hold the address. Okay. Address of what? Yeah. PTR will hold the address. This you have to remember. So now there is a int var. Okay. This is an integer variable. Where is present at an address. Okay. At an address where? Okay, we don't know. It's present at stack address. In stack memory. Yeah. In stack memory it is present. Okay. So now point address of var to PTR. Okay. Let's see how to do this. I have defined it here. Use PTR, not star PTR. Use just PTR. Address of var will get using this AND symbol. Okay. AND of variable will give me address. So now what I'm doing here is I'm taking address of var variable and assigning it to PTR. Okay. So this is, so far it's clear. So now let's print. Okay. Whatever we have captured, let's see what it will print. Just for time being, I just assign it to 10. But this is not assigned here, but whereas this is assigned here, we made it to point this one. Okay. Address of var is equal to this one. Okay. Correct. And now I also want to get the address. Okay. PTR. So both should be same, and var and PTR. Address pointed by PTR is equal to, okay, this is missing here. That is equal to this one. Just PTR. Don't write star PTR. You just have to write PTR. Let's compile it. Okay. The compilation is through. There are no errors. And this is what we have. Okay. Just take it down. Yeah. We can see address of variable, address of var equal to this one. This is address. Okay. So at this address, what is stored? 10 is stored at this address. And PTR, which is a pointer variable, that's also pointing to same address. How do we get same address here? We have used AND var, which has given me the address of variable. But whereas here, I made this PTR point to this address. Okay. That's why I used PTR here and we got this one. So this is about the address. So we were able to get the address now. So what I'll do, I'll just copy this address. Okay. Just for explanation, I'll copy this address. Just write it here at this address. Oh, somehow it's not being copied. Yeah. So 6422036. Let me run and see again. Is it the same? Yeah. 6422036. 6422036. It is at this address. This is the address. So now what we know is this is a pointer. And the moment we use star, we get the value. Okay. So I'll use star here. Value at address pointed by this. Okay. So now I should ideally get 10 here. See, this is 10. Why I got 10? I used star. Okay. Whenever I use star, what we know, this is the address. 6422036 is the address. That's where this variable, this var variable is present physically, and that has 10 in it. When we do star, we get that. Now say we directly know the address, like how we know now, we directly know the address. Okay. So can I do this? This is possible. With this, I have to typecast this. I have to make it an integer pointer. Otherwise, it will be treated as a integer itself, right? This is an integer number. Just that we know this is an address. This address is an integer number in itself. But if we directly pass it like this, it's like it will interpret it as integer. Then we have to explicitly tell it, no, this is not integer. This is an address. Okay, because address is also integer. Let's see what we get here. Exactly. See, we haven't written star PTR, okay? But what I did is I wrote this one. Yeah. So now we can easily say, here I'll write in comments, okay? Star PTR is equal to this. Yes or no? Okay, I'll copy this, sorry. Star PTR is equal to this. Yeah, because PTR is pointing to this one. Star means get the value, whatever is present at this address. So that's what we did here. Okay. So this is how you can access the memory and retrieve the data, even though you don't know, only you know the address. Okay. If you only know the address, you can still extract the data from that address. This is a perfect example where we want to retrieve an address or a data from a register in the embedded world, where we know the address of a register from the data set or the manual of a board. Okay. So then we can directly use this and get the address, get the data from it.